Hi everybody, my 130s. So today I'm going to be making a video about your final exam review, kind of the end problems from chapter 8 and 9. So let me go ahead and write this in today. So I'll just write it right here today. It is 5/26/2020. And I'm going to go over final exam review, numbers 46 through 52. So that covers end of chapter 8. That's going to be number 46 through 50. And then chapter 9 material that you're responsible for, that'll be number 51 and 52. Okay. So let me save that. I'm going to go ahead and clear that out, and then I'm going to get started here. I'm actually thinking it might be best to do these on the whiteboard. So let me go ahead and just take a quick snapshot of these. Okay, snapshot taken. All right, so I'm going to go ahead and stop my share for a moment and then share a whiteboard with you. Blow that up. Okay, here we go. Okay, so first one I'm going to start out with is number 46. And I'm pretty much assuming that you've already done some research on this. You've been studying up using Alex to figure out some of these problems and read up on it. So if you do encounter questions along the way, just make sure to ask me. Okay, so we're asked to solve for x. And we are given 4 natural log of the quantity x plus 1 equals 20. Round to nearest 100. Okay, so a little bit of background. First, note. We've been talking about logs in some of the previous videos, and essentially, if I have something like log 5, here my base would be 10. And remember, that's the part that you can't see. It's typically written here when your base is not 10. Okay. All right. And your argument is whatever's next to the log. So in this case, it'd be 5. If you have log base 2 of 5, means my base is 2. And my argument is 5. Now we introduce natural log, ln. We'll just use 5 as a number still here. Okay, ln is the same thing as log base e. Okay, so in this case, your base is the irrational number e, and your argument would still be 5. Okay, so notation, ln of x is the same thing as log base e of x. Okay, and to give you a little bit more background, just a little bit here, if you actually look at what the number e is, it equals 2.718281828, and it continues. It's an irrational number. All right, so let me just save that. Now you're also going to need to recall your log rules here. Remember, we talked about 3 main ones. One was the product, one was the quotient, and one's the power rule of log. And sometimes you can hear this called product to sum and quotient to difference, but the main thing is just noting this. So if you have log base a of x and you add log base a of y, you combine the logs into one, so log base a, but now you're going to multiply the arguments x and y. Okay. So where you see this plus on the side with more than one log, it becomes a multiplication on the side with one log. Continuing down the line, you have log base a of x minus log base a of y. That's going to equal log base a of x divided y. And let me emphasize, these will matter too. Okay. All right, last one, power rule. If you have a coefficient out front in front of your log, when you compress your logs, that exponent comes up into the argument of the log as a power. Okay, so see how that coefficient comes up into the argument and becomes the exponent for the argument itself, x. Okay, so we're going to need those rules. All right, so let's go ahead and get started here. You actually have choices with this particular problem. Now let me save a picture of this. I'm going to clear this portion out, okay? Okay, we'll keep the notation. There we go. Okay, so let's do this one. We'll go ahead and start it in black. So you have 4 ln of x plus 1, that equals 20. So your first goal is to isolate the log. Okay, remember ln is also a type of log, right? So to do that, what we're going to do is divide both sides by 4. So we have ln x plus 1. That's going to equal 20 divided by 4. So that means ln x plus 1 is equal to 5. Okay, so we just simplified right here. Okay, now the next thing is you have to remember how to go back and forth between log form and exponential form. So let me add another little note here. I would highly suggest watching the video I put out for chapter 8 and 9 homework alternate on these problems. So a note here. Remember you have exponential form and you have log form. And you can go back and forth between the two. Essentially, you have a how do I want to color code this? That's fine. A to the x equals y. Okay. A is your base. X is your exponent. And y is your argument. It's going to be the same over here as well, it just changes your form a bit. So now we're going to have a log. We're going to write our base, a, right below the log. We're going to write our argument right next to the log. And then we're going to set that log portion equal to the exponent of x. Okay, how does that help me here? Okay, well, next goal, use exponential form to remove the log from the variable x. Okay, so the first thing that we're going to want to do is remember that natural log, okay, is going to be log base e your argument in this case is going to be the x plus 1 you have right here. You're going to have your equal over here, and then you have 5. That's eventually going to become your exponent. So see what I did here? I just changed the format ln into log base e. And now I'm going to use exponential form here to get the x, the variable outside of the log. So now that's e to the 5th equals x plus 1. Okay, so here I had log form, and then I went to exponential form. Now, the exponent's of 5, and e is an irrational number, so e to the 5th is just a real number. Okay, so what I'm going to do is continue to simplify. So in this case, I'm going to subtract 1 from both sides. You have e to the 5th minus 1 equals x. Okay, so we solved for x, and now we have to evaluate this. Okay, what is e to the 5th minus 1? Let's see if I can gently move all this up without messing anything. Okay. Let me undo that and try this again. Man, I hate this thing sometimes. One more time. There we go. Okay, so you see how we have x isolated. Now we need to round. To the nearest hundredth. So what we're going to do, x is equal to e to the 5th minus 1. You're going to plug that into your calculator. And let's leave the exact version first. So if I put in e to the 5th and then subtract 1, x is 147.413 and some change. So x is approximately 147 point, nearest hundredth. We need to round at the 1. So we look to the right of it at the 3. We have 4, 1. Okay, let me save that. Kind of wonder if I could just copy this part here. I don't want to have to rewrite it, but it's okay. All right, so let me go ahead and save that. I'm going to clear this out, and we're going to move to number 47 next. Number 47, we have another log problem. Okay, put all this. Okay, so for number 47, we're asked to solve for x again. And the equation given this time is log base 2 of x plus 4 equals 2 minus log base 2 of x plus 7. Okay, so for this part, we're going to need our log rules. Essentially, what you're going to want to do for the first step, get all log terms to one side of the equation. Okay, I'm going to erase this too. This stuff will still need. Okay, so get all your log terms to one side of the equation. So essentially the way to do that, you see how we have the subtract log base 2 of x plus 7 on the right side here? We're going to just add to both sides. So for this part, I will be a little bit more detailed. So we're going to add log base 2 of x plus 7 to both sides. Be careful here. You're not going to actually like combine your logs at this point. You're just going to have your log base 2 of x plus 4, the quantity, plus log base 2 of x plus 7, the quantity. That's going to equal positive 2. This is when you want to look at your log rules. Combine logs using log rules. What's the goal of that? Well, once we combine these logs, we'll be able to go into exponential form. Okay, that'll take the x's outside of the argument. So go ahead and combine your logs. You have log base 2, and then you have x plus 4 on the top. And then, hold that thought. Let me extend that. Let me also color code this a little bit. Note there's a plus here. So we're going to want to use the product rule of log. So we're going to get x plus 4 times x plus 7. Okay. That's equal to 2. So let's write that a little smoother. So log base 2 of the quantity, x plus 4 times x plus 7 is equal to 2. Okay, let's go ahead and save a picture of this, and then I'm going to erase the log rules now, as we're not going to need them again right now. Okay, and then let me finish this up here. So now what we're going to do, we're going to go into exponential form. From log form. Okay, so what we're going to do, realize that here your base is 2. You're taking that to the power of 2. And then setting that equal to the argument inside of log here. Okay. Simplify. You have 4 equals x plus 4 times x plus 7, the quantities. So this is actually going to be a quadratic. And we should know how to solve quadratic equations by this point. So now solve the quadratic equation. Okay, so we have 4 equals, we're going to FOIL over here. That's x squared plus 7x plus 4x plus 28. 4 equals x squared plus 11x plus 28. We're going to subtract 4 from both sides. And 24, 8, and 11. I'm going to factor this. Remember, you can use AC method if it's not as quick. So 8 and 3. X plus 8 and x plus 3 are what we factor into. So what that means is x plus 8 can be 0, or x plus 3 can be 0 by zero product property. Okay, let me save this. So what this basically is going to tell us before I start erasing some things, x is going to be equal to -8, or x will be equal to -3. Okay. All right, so now what we're going to do, remember how I told you guys that for chapters 5 and up, you need to check your answers for your equations when you come out with a solution. So let me go ahead and clear all this on this side. So always check solution. Okay, so let's start with x equals -8. You could definitely use a calculator for this, but you'll need change of base in order to do so. So we have log base 2 of -8 plus 4. We want to know if that equals 2 minus log base 2 of -8 plus 7. Okay, now you can simplify before even needing to think about a change of base. Okay, now just a hint to you, this is not going to work here. I need another color. I'll just use dark red. So right here and right here, okay, you can't have negative numbers inside the argument of log. Okay, so the reason for that, because it's log base 2 of x, whatever x is, it's got to be greater than 0, or else it'll be outside the domain. Review how we graph logs, and that should help you to understand that concept. So I already know that x equals -8 is not a solution. So we cross that one out. Okay. Let me erase this stuff over here. We're going to change this. Okay, so when we have -3 for x, log base 2, -3 plus 4, that equals 2 minus log base 2, -3 plus 7. This is log base 2 of 1. We want to know if that equals 2 minus log base 2 of 4. Okay, so change of base. I discussed this in a previous video as well. Basically, if I have log base a of x, and I need to evaluate it with a calculator. Okay, so essentially your calculator only uses base 10 and base E. Those are the log buttons and the ln buttons in your calculator. So what you would need to do for this in order to use it in your calculator, you would need to change to log x divided by log a, or you could say log base a of x is equal to ln x over ln a. Okay, so for this side over here, log base 2 of 1, that's going to be log of 1 divided by log of 2. You want to know if that's equal to 2 minus, we're going to have log of 4 divided by log of 2. And now we can just plug this into our calculator on either side. Just be careful, especially if you need help maneuvering your calculator, let me know. Okay. All right, so log of 1 is actually going to be 0. One of those special log rules. Oops. There we go. Yep, just double checking it. So log of 1 is going to be 0. Still have log of 2 here. And 2 minus log of 4 is not quite a nice number. It's a decimal number. So what you're going to want to do for this side, you're going to put log of 4 divided by log of 2 together, and then subtract that from 2. So hopefully you're already seeing on this side, any number divided by, 0 divided by any number is 0. On this side, I'm going to go ahead and put in my log of 4 divide log of 2. And when I do this part, it gives me 2. So let me know again if you need help doing this portion. I know that the logs are definitely a little bit abstract compared to what we've been working with in the past. So reach out. We have about a week left. Okay, so what we found is that the solution to this particular problem, solution, x equals -3 only. Okay. All right. Just trying to do this thing where I have shorter videos instead of really long ones that you have to maneuver through. I'm going to start a new video to go over number 48 and 49. Okay.